1. Pre-process. Sorting before cutting and polishing begins. The rough diamonds may need to be sorted into categories to help with workflow and prioritize certain rough diamonds to complete orders. The teams may look at model color clarity fluorescence strain and assess the need for window polishing, where one or more very small facets are polished onto the rough to allow the planner to make a more accurate decision around clarity features. 2. Planning and marking. Planning is the process of deciding how to cut and polish a diamond to maximize its value. In today's manufacturing environment, planners use a combination of their skills and technology. The planning stage includes creating a 3D surface model of the rough diamond, not used for small diamonds due to cost. Plotting clarity features. Planning the cutting and polishing to maximize yield. Pre-process sorting. Once the plan has been chosen, if the stone needs to be cut, it will be marked by pen or automated laser marking to show the cleaver sawyer where the cut should be made. It is during this planning stage when the decision on whether to saw, cleave, or polish the diamond will be made. 3A. Cleaving. Many diamonds require dividing into more than one part to get the best overall yield and/or clarity. One process used to divide a diamond is cleaving, and is often performed on stones where the structure has internal cracks and fractures, so a better overall clarity can be achieved with its removal or avoidance. The cleaving process involves kerfing the stone, the creation of a notch or groove that will enable the cleaving. This can be completed manually using another diamond, or by laser. Cleaving the stone into 2 or more parts between the crystallized layers along the lines of its growth is completed using a sharp blade. This will remove the heavily included area of the diamond. Laser kerfing is highly accurate, allowing precise control of the location, direction, width, and depth of the kerf, and even the removal of small pieces of diamond. Diamond cleavers need an extensive knowledge of the structure and qualities of diamonds. Cleaving is preferable to sawing wherever possible, since it involves less wastage. Diamond cleavers need exceptional skills and in-depth knowledge of the structure and properties of diamonds. They must understand the inherent potential of every individual stone. Their familiarity with the different types of rough stones enables them to maximize the potential of every gem, especially those with a complex or heavily included structure. 3B. Laser sawing. Laser stands for light amplification by the stimulated emissions of radiation. It has revolutionized the diamond cutting industry, offering savings in time and money. It enables the cutting of material that would have been unworkable previously, and can greatly reduce the risk of damage. It also allows an almost limitless assortment of fancy shapes, as you're not restricted by the crystal structure of the diamond. The reason you are not restricted is because the laser burns the crystal structure. Once the stone has been laser sawn, it looks blackish and opaque. Cleaning procedures return it to its original appearance. 3C. Sawing blade. Sawing can only be carried out on a diamond in certain directions, which are different from the cleavage directions. Before any sawing takes place, the stone is marked with a line where the blade will divide the stone. The sawing machine consists of a metal frame that has a weighted arm mounted from the back. The diamond is held in a clamping arm that is mounted on the arm above the saw blade. At the rear of the arm, there is a counterweight which controls the lowering of the diamond onto the saw blade, allowing the sawing action takes place. The sawyer can be responsible for multiple machines and is in charge of changing pressure of the weight and applying sawing powder to the blades. It takes approximately an hour to an hour and a half to saw 1 ct of diamond. During blade sawing, weight loss of approximately 2% is expected. 4. Brooding. Brooding is the process of rounding or shaping the diamond by rotating it against another diamond. The cutter works on sawn, cleaved, or whole stones. At this stage, the stone receives its precise shape. the exact diameter and location of the girdle, and the locations of the table and the culette. 5. Blocking. Blocking is the process of creating the basic shape of the diamond. It involves the polishing of 8 facets on the crown and 8 facets on the pavilion of the diamond. Blocking the pavilion section of the diamond will form the culette, where the 8 lower facets come together to form a point. These 8 facets are polished at the same angle. Blocking the crown is the process of creating 8 facets at the same angle while forming the table. Blocking can be done on the polishing wheel setup. 6. Brilliantiering this. Brilliantiering. This is the final stage in transforming the diamond. The operator will polish the bottom facets, creating the 16 lower girdle facets and the 8 pavilion facets. They will also polish the top facets, creating the table, 8 star facets, 8 bezel facets, and 16 upper girdle facets. This is for a round, brilliant cut, but the same method is deployed for fancy shapes, albeit to different shape plans. 7. Final quality check and any repolishing. As the transformation comes to an end, the final stage is a quality control check to look at yield as well as proportions, symmetry, polish, clarity, naturals. These are small areas of the natural rough diamond surface which have been deliberately left on the polished diamond as proof of efforts to maximize yield. If any naturals are too large, they may be rejected and returned for repolishing. The quality checking process involves the use of microscopes as well as loupes, and will ensure that the best diamond is finally released from the rough crystal.